Hi students, this educational video is a part 2 of a series of educational videos handling the sizing of the principal elements of the pressure vessel based on the French calculation code CODAP. I will try in this part 2 educational video to technologically explain how to determine the appropriate sizing condition, service condition, or hydraulic test condition. Okay, let's go. Well, it's to note first that theoretically we have to determine the thickness of the shell or of the formed head of the pressure vessel under the service condition defined by its surface pressure and surface temperature, and also we have to determine the thickness of the shell or formed head under the hydraulic test condition defined by its test pressure and test temperature. And finally, we have to take the greater thickness between the service condition or the hydraulic test condition. But practically, we have to use this formula which states that the sizing condition, service condition, or hydraulic test condition is defined by the maximum between PS divided by Fs and PT divided by Ft. Of course, PS here refers to the surface pressure. Fs is the maximum allowable stress associated to the surface. Pt is the test pressure, and Ft is the maximum allowable stress associated to the test. It's to note here that the test pressure Pt is given as the maximum between 1.5 ps, ps of course is the surface pressure, and 1.25 ps multiplied by the maximum allowable stress associated to the surface, measured at the temperature of the test, divided by the maximum allowable stress associated to the surface, measured at the temperature of the surface. Pay attention, the Fs at t-test is not Ft. Fs at t-test, as I said, is the maximum allowable stress associated to the surface, but measured at the temperature of the test, and Ft is the maximum allowable stress relative or associated to the test. So Fs at the temperature of the test or Fs at the temperature of the surface are determined using the formula stating that Fs is the minimum between the yield strength, which depends on the temperature. Here is the yield strength at 0.2% strain, divided by 1.6, and the tensile strength R divided by 2.7. But you can notice that Ft is obtained as 0.95 multiplied by the yield strength at 0.2% strain. Now I will explain how to determine the yield strength and the tensile strength. Based on this table, we can determine the yield strength at 0.2% strain and the tensile strength at the ambient temperature, which is generally close to the test temperature. And as you can see in this table, based on the material of the shell and based on the thickness of the shell, we can determine the yield strength and the tensile strength. For example, here in our case, we have the steel A48 as material for our pressure vessel, and based on the pressure, the surface pressure, which is 8 bars equal to 0.8 megapascal, and also based on the steel grade A48, we are sure that the thickness of the shell will not exceed 30 millimeters. So for us, in our case that I explained in the previous video, we have a yield strength around 285 megapascal, and we have a tensile strength around or varying between 470 megapascal and 550 megapascal. This table is used so to determine the mechanical properties at the ambient temperature, which is, as I said, close to the test temperature. And these mechanical properties should be determined in order to determine the maximum allowable stress, as I explained in the previous slide. Now, we have another table which permit to determine the yield strength, RT, in higher temperatures, which are close to the surface temperature. So we have the steel A48, and I explained in the previous video that the temperature or the surface temperature is 170 degrees Celsius, between 150 degrees Celsius and 200 degrees Celsius. In sorry, in 150 degrees Celsius we have a yield strength around 245 megapascal, and in 200 degrees Celsius as surface temperature we have a yield strength around 230 megapascal. In order to obtain the yield strength in the surface temperature 170 degrees Celsius, which is between 150 degrees and 200 degrees, we have to carry out a linear interpolation. Now we will numerically apply the sizing condition, so we have to determine PS divided by Fs and PT divided by Ft. So PS, which is the surface pressure, will be equal to 0.8 megapascal, as I stated in the previous educational video. And also we have Fs, which is the maximum allowable stress associated to the surface, which is equal to Fs at the temperature of the surface. We determine its value as 149.38 megapascal. It's to note here that the yield strength at the surface temperature, which is 170 degrees Celsius, as I stated in the previous educational video, is calculated, and its value is equal to 239 megapascal. This value is obtained as a linear interpolation between 150 degrees Celsius and 200 degrees Celsius at the temperature 170 degrees Celsius, as I explained in the previous slide. Now we have PS and Fs, so we can determine PS divided by Fs. Now let's move to PT divided by Ft. PT is obtained by the formula that you see now and that I explained in a previous video. So Fs at t-test is calculated as 174.8 megapascal. We determine PT as 1.2 megapascal. We determine also Ft as 278 megapascal. So we can determine PT divided by Ft. Now all the calculations are carried out. So the sizing condition is the maximum between 0.8 divided by 174.8 megapascal as PS divided by Fs, and 1.2 divided by 270.8 megapascal as PT divided by Ft. It's clear now that the sizing condition will be based on the surface condition, which is defined by its surface pressure PS and surface temperature TS. That's all for this educational video. Please, if you have any remarks or suggestions, mention it in the comments. Thank you very much.